Now it's time to announce our very first keynote, and I'm really happy to welcome Gareth McCumsky, sorry for that, right here and this morning at our Serverless Architecture and API conference. Good morning, Gareth.
Good morning, and thanks so much for having me for a talk today about serverless. I love talking about lazy techniques. It's pretty awesome.
Cool. So, I'm really glad that you are here. And because I just said everything is live, where are you based?
I'm actually based out of Portugal. Recently moved here with the family. So that's why things sound a little echoey, because we're still getting everything set up.
Okay.
Yeah,
Okay. Nice move, moving to Portugal. Okay, that is great. That is, on the other hand, the good news about remote work and remote conferences. You really get kind of flexible where to go to, and you really get access to your network, to your customers, and all these things. So I really like that.
Yeah, and it's been great for us too. With serverless being remote, means they don't really mind, and you can go where you want to be.
And that's exactly the topic of your talk, of course, yeah? Because the title is Why Local Development for Serverless is an Anti-Pattern. So you're talking about, let's say, the interdependence or the influence which the social factor and the technical factor have vice versa, right?
It's actually more focused on why trying to run your serverless applications on a local machine it might not be the best thing to do, and you should probably be testing things in the cloud directly.
Okay, cool. So having said that, I'd like to hand over the welcome keynote stage to you, and I'm really curious to hear what you're saying about local development as an anti-pattern for serverless. Gareth, go ahead.
Thank you so much, Sebastian. And I'm going to grab a screen share here, and I'm going to assume everybody can see that because Zoom says everything as well. It's good. And thanks so much, folks, for, again, letting me join you folks on the Serverless Architecture Conference today. I love talking about serverless stuff. And local development for serverless is one of those topics I like to talk about quite a lot. It's quite a big deal for me. So being able to get exposure to more people and chat to folks is always great. But first of all, who is this Gareth McCumsky guy? I am a customer success manager at Serverless Inc., the creators of the Serverless Framework. You may have heard of it. And I've been in web development professionally since about 2008, and started building serverless applications in about 2016. And really, my role is to work with people interested in serverless, who want to build serverless stuff, who have questions about it and need answers. And that's what I do. So if at any point anybody does have questions, or feel free to drop it into the chat. If you're shy, feel free to email me. My details are on the screen, or on Twitter as well. I'm also open to messages there. So all of that out of the way. Oh, and one last thing. We may hear the screams of Domesticus Macumskius in the background. There are children in the house getting ready for school. So my apologies ahead of time if there happens to be some noise. But, be that as it may, let's crack on with it. All right, so to get us started, there's quite a lot to talk about, so I'm going to try and be as quick as I can. Again, if you have questions, please feel free to ask. But I want to start off with trying to describe what I mean by local development. Where does it come from, what it is, and why do we care about it? And if you think about it, local development is really about you want your machine to act like production. You have some code that you're writing to accomplish a certain goal, and you want to make sure that it actually works. And to be perfectly honest, it's too expensive to expect every developer on a team to have an exact replica of what the production systems look like, to develop on a daily basis. I mean, that would be the perfect, most accurate way of doing things. But in this day and age, it's just way too expensive to be able to replicate those in the traditional development sense. It's also, the other alternative would be to just develop things directly on production, but this gets way too risky for very obvious reasons and stopped being a thing a very long time ago. So what we end up doing is we try as best as possible to copy our production environments onto a developer's local machine to allow them to try and build what they need to on themselves before pushing it into any kind of production system. And in a lot of cases, teams will have an environment where they have a development server in between local and production, just as an interim step to help solve that problem. And this is where we get to the problem with it worked on my machine. This is a meme in the development space. It worked on my machine until I gave it to the ops team, and now it doesn't work in production anymore. It's not my problem. This is potentially what the problem with local can cause. But local development has given some advantages to teams in the fact that in the development sphere, but by developing locally, you now have access to local tools like being able to step through code and breakpoints, debugging, and so on.
Excuse me, Garrett. Sorry, can you hear me?
Yep.
Yeah. We got an audio problem. I'm very sorry for that, but I would say we just try to fix it. And please, dear audience, give us a minute, and then we are going to fix it, and then we can have a better audio solution. Yeah. 1 second, please. Yeah. Or 1 minute, please. Thank you so much for your patience. It seems that we now could fix the audio problem. Thanks, Gareth. And now it's time for you to continue. Sorry for that.
No worries. Thanks, Sebastian. It seems like Sebastian didn't catch all the technical gremlins for me. So my turn to snag a few. And yeah, let's get carried on with the screen share. Awesome. All right. So as I was trying to continue saying, one of the advantages that something like local development gives us is that it lets us use tools that sometimes desktop environments, normally the desktop developers would normally be able to use on the web, things like breakpoints and stepping through code. But in order to get us closer to these, I'm glad to hear it's much better. But in order to help us get closer to production on local environments, we've used tools like Vagrant to help us create virtual machines that then spin up lots of virtual machines on our local. And this has been subsumed a lot by Docker these days, where Docker now takes over a lot of the virtual machine work that we would have done. And local development is one of those things that has become just standard in development. You start with a new team or as a junior, and the first thing you're going to end up doing most of the time is sit with somebody while you get your local development environment up and running. Maybe this takes a couple of hours, maybe a day, maybe 2 or a week. Or in some cases, you join a team that doesn't have one, and now you're the one who has to go and build it. And I've been involved in setting up and trying to build local development environments to as closely match production as possible, because we want to reduce that load of working locally and it breaking in production. And those processes can take weeks sometimes. Literally has happened to me as well. And production environments are just getting more and more complex. As you add things to your production environment, this means you now need to go back to your local environment, add these changes you've made in production, try and force that across your entire development team. It starts getting to be a really big job to maintain over time. But how does serverless change this? We're now in a serverless world, and how does this impact and change how we manage our local development environments? And first thing, I tend to look at things from the point of use cases, and for me, the biggest use case is web, usually APIs, so kind of appropriate. And in the past, you would normally have a web server sitting on a machine that you would be running in production, normally an Apache or Nginx web server of some kind. In the serverless world, though, we tend not to use these kinds of tools. We'll use something like API Gateway. And trying to do something like replicate API Gateway locally tends to be a bit of a fool's errand, because API Gateway isn't Apache or Nginx. It's just not the same thing. It is a very, very different service. It doesn't just catch HTTP requests and forward them almost dumbly to code somewhere that's then going to execute on them. And what I mean by this is, if you look at something like, this is a Laravel routes configuration, a very simple one. If anybody's worked with Laravel, they'll realize this is quite a simple routes configuration. But this is the kind of thing that you'd have to define and get it set up in code yourself. You'd have to install a library or a framework of some kind. That's code to maintain and upgrade and keep going in future. Code you'd have to write to manage this interaction. It means more work for you. In the same way, if you're managing database access and entity relationships, this is an entity class in the Doctrine ORM that's often used in PHP frameworks. Again, this is, if you want access to database, this is work for you to build, maintain, and so on, and that you have to do over time. And cron jobs, it's another thing that sometimes people forget about, is that in order to run cron jobs in a traditional server sense, you'd need to have a machine somewhere that you can go and insert a cron job line into, and you have to worry about and maintain that over time. But if we look at the serverless world, we have services available to us that can let us do these things. And we have configurations that let us bypass having to do these kinds of things in code. So A serverless.yaml file for the serverless framework, for example, will define a path to an endpoint, but that's where it ends. API Gateway takes over from there. There's no code that I'm writing to manage this routing and this pathing and so on. And my Lambda function doesn't have to worry about maintaining that sort of root configuration either. And a similar thing happens with databases. I can define a DynamoDB table very simply in my configuration, my serverless.yaml, but I don't have to worry about maintaining entity relationships necessarily, and those complex tasks, they can take time to maintain. And it spans across the AWS services. We have services like SNS, for example, which is essentially PubSub as a service. I don't need to install and instantiate a library in my code that then allows me to perform a PubSub type pattern. I just use the service. Message queues, SQS, it just does message queues. You don't need to worry about running your own message queue system or code. It's message queues as a service. Step functions, I have state machines as a service. Very complex thing to do in code, very simple to do as a service. And those cron jobs, well, CloudWatch lets me run cron jobs very simply and easily. I don't need to worry about maintaining the underlying systems that just execute that code every day or hour or whatever it is that I need to run. And all of these services help me incredibly. They make me very lazy, as Sebastian so eloquently put it. But what does all of this mean, using all of these services? Well, first of all, as I think I might have pointed out, this makes us less dependent on our own code. This is useful because now we just have less code to worry about. And having less code means there's also less chance of me introducing bugs due to code. Most bugs happen because of code you write. Who knew? But it also means that now that I have less code, there's less code for me to have to execute on my own machine anyway for testing purposes. So that helps me a lot in this local testing environment that we're talking about. And cloud services are now integral to our application. You get to a point where you can no longer extricate the cloud services you use because they're critical. It's not just EC2 where you're going from one CPU on your computer to another CPU in the cloud. You're intricately embedding these cloud services into your application, and that's exactly the point. That's what we want to do as serverless. We want to consume these services to make our lives easier and get to delivery faster and so on. That's why we do serverless stuff. And now that we kind of have looked at what local means and so on, I want to take a look at setting things up on local and the different techniques that I've seen teams use over the years and their advantages and disadvantages and so on. And we're going to get straight into probably the simplest way to try and run things locally. The serverless framework and many of the other serverless frameworks out there have a method for you to invoke code locally. SLS invoke local is obviously the one for serverless framework in this case, and it's the quickest and easiest way to execute code on a local machine. However, it makes getting access to AWS services a bit tricky. So it doesn't necessarily solve the problem of testing against AWS services. And of course, the downside of running code in a local machine means that you're not quite, it doesn't quite emulate the conditions of Lambda itself all that accurately. So SNS local is simple, but let's take it one step further. And let's take a look at something called serverless offline, which I'm sure many folks are very familiar with if you've used the serverless framework. It's a relatively simple tool to implement. And the biggest downside of it, however, is that it only really supports HTTP events. So it's very quick to get up and running, very quick to help you get some testing done, but only on your HTTP events. So if you have any other AWS events that you want to use, like an S3 or DynamoDB or SNS or SQS, serverless offline is going to create a problem and either prevent you from using those services because it affects your local testing, or serverless offline cannot be your only solution to that. And it also requires you to run something like LocalStack in order to run those AWS services in some fashion so that you can actually test against them. Otherwise, you'll still have the same problem as SLS invoke. And of course, if you're executing code locally in some way, it doesn't quite emulate the conditions of the Lambda environment all that accurately. So about this emulation of AWS services and how can we accomplish this? And there's a very, very popular tool, and it's a very powerful and good tool called LocalStack. I'm sure most folks who've looked at setting up serverless development environments locally have heard about LocalStack and given it a try. There's even a plugin for the serverless framework. So if you want to use it with the serverless framework and try and make your life a little easier, there is a plugin for it. It does unfortunately have some downsides, as everything does. And like most local development environments, part of the problem is complexity. And this is a serverless.yaml file that shows a relatively simple configuration for setting up LocalStack in a serverless environment. And it can get pretty complex and something you have to make sure you've got up and running and maintained. But it also introduces the possibility of issues cropping up. And this is one of maybe a dozen images I've seen of folks trying to find solutions to problems they're having using LocalStack. I'm not picking on the LocalStack team. This happens if you're building development environments traditionally or in the serverless world, and you want to do this kind of emulation locally, you're going to come up against these kind of problems where you need to maintain these stacks, and they can consume a lot of time and effort. It also introduces complexity just on your machine in general. You now have these large number of processes now executing on your machine. So if your dev team happens to have pretty light machines that they build on, having all of these background processes running may or may not be an issue for you, and that's just something to consider as well. Unfortunately, it doesn't end there. LocalStack has a couple of other potential downsides to consider in that, like the other solutions, LocalStack just isn't equivalent to AWS. It tries as best as can to emulate AWS services locally for you. Unfortunately, these are open source packages that have just been configured in a way to look like AWS services. So they're just not the equivalent. And it also leads to another problem, and I've hinted at it with serverless offline. A hypothetical situation, you're building your application and this amazing AWS service you've just spotted looks like it's absolutely incredible and will do amazing things for your application. It'll solve a lot of problems for you, get you to market faster, optimize your application amazingly. However, it's not emulated in LocalStack for you. So now you're left with one of two choices. You can decide that, okay, well, we can't emulate it locally, so I just cannot use the service. So now I'm hamstringing my application and making it not as optimal as it could be because my local development environment can no longer support it. Or the alternative is I use that service anyway, but now I can't test locally anymore because I have a service I can't emulate locally. Neither of those are a good situation to be in. And it has something that has occurred multiple times for myself, trying to use LocalStack in development. We have to make this tough decision. Of course, if I'm executing Lambda code locally, I've also got the issue that the Lambda environment isn't very accurately emulated locally when I'm actually executing my code. So that's also a potential downside. So how about one step further? How about looking at mocking these services potentially? And this is a technique that I've used in the past quite successfully and even written blog posts about. And it's actually very easy to set up. There's an NPM module called AWS SDK mock that lets you do this and catches calls to the AWS SDK, for example, and lets you mock them locally. There's no complex configuration needed and no complex installation of applications that you need to get up and running every time a new developer joins your team. So that's pretty handy. There's also no maintenance because you don't install large complex sets of services. There's no maintenance required, none of these major errors that can happen. And it also doesn't limit the services you can use. If it's in the AWS SDK, you can mock it. However, there are some downsides. Again, your mocks will not be equivalent to AWS, even if your responses to calls to AWS are exactly as AWS would give them. It's still not equivalent because you still cannot replicate the network latencies involved between services. That is definitely a thing that can affect your application. You can't reliably replicate IAM, so you may have IAM issues that you're not aware of until you go into production potentially. So yeah, unfortunately, mocks just aren't that close to AWS. And setting up the mocks themselves can get incredibly time-consuming and tedious because you need to write the potential to catch a request to an SDK, respond with a success, respond with an error, respond with any known error potentially. But creating these tests also requires you to write unit tests to some degree because you need to find a way to execute your Lambda code. You need a way to spin up and bootstrap the SDK mock tools and so on. And really the only way to do this reliably is through unit tests. So whether you want to or not, you have to write unit tests to actually get this local testing to work in any way with mocks. And again, the issue is that I want to run Lambda code locally, and that probably doesn't emulate the Lambda environment very accurately. So one of the techniques that we've used at Serverless, and I see a lot of folks use more of, is a hybrid approach. So instead of trying to emulate local services, you run your code locally, but you actually use the actual AWS service in the cloud itself. So it eliminates that issue of services, so there's no need to emulate them. And your code is running, you can still use those local debugging tools that you might want to keep in. And at this point, most folks are going, isn't that good enough? Unfortunately, I still don't think that's good enough. And for one simple reason, for a couple of some kind of special configuration to get stuff working locally that then might get deployed into the environment. I'm not a big fan of having my development only configuration also being in production, and that I've set up my development only config reliably so that it doesn't affect production. Seems like a code smell to me, and I'm not necessarily the biggest fan of that, but be that as it may. Again, I'm still running code on my local machine, and it doesn't really emulate the conditions that Lambda functions actually execute under in the cloud. So I've said this quite a few times now, and folks are wondering about the set multiple times. It just does not emulate the Lambda environment accurately enough. First thing I'm just going to blast right through is differences in library, because this is the most obvious one that most folks think of. You write your code locally, it seems to work, you deploy into the cloud, and you get some error about a missing library. This can often be configured by bundling the library binaries with your function. Not a great thing to have to do, but that can work. Using alternative NPM modules can sometimes solve the problem, and containers can often mitigate that as well with the new container support that you find in serverless. However, this is you develop, spend a lot of time local, then you push it into the. But for me, the big issue is about the way that code is executed in Lambda to local. And this is just one example of that, where you can execute code locally that never actually executes in the cloud. And this is most apparent in JavaScript when you have the JavaScript call stack. But it does occur in other runtimes as well, where, for example, with JavaScript, if you make a request to a database or an HTTP request in some way that you haven't async awaited properly, or whatever it may be that you're using, that call gets shoved onto a call stack. The call stack is now waiting to execute when the main thread of your Lambda function is finished. But Lambda doesn't do that. Lambda will kill the execution of everything else once your Lambda function has completed execution. So if you have anything on that call stack, it's essentially just dropped. Well, sometimes it's dropped. Sometimes that stack stays there until the next time this warm Lambda function now gets invoked again, and now that call stack is suddenly executed in completion. Now I have code that may or may not run sometimes and do things when I don't want it to. The next time it becomes a bit of a mess to manage and maintain. And now I end up in this situation because I've tested locally. I think this is all working as I need to, and I've pushed it into production, and I'm hitting this potential issue. So how do we go ahead and test serverless applications in a reliable way using the cloud? And one thing I need to just point out is that the barriers that we had developing locally are now gone, because in the past it was just too expensive to expect every developer to have production replicated locally. This was just something we couldn't do because of the cost. But these days with serverless, every developer can actually deploy into the cloud for free or very little, due to the way that these services that we use in the cloud are priced. And one of the practices we see a lot these days is that every developer in an organization now gets their own AWS account. And if this sounds like a scary thing to you, check out AWS Organizations, a service in AWS to help you manage that. It's pretty awesome and helps make your life a bit easier in that way. But also, serverless is cloud native. We're building applications that depend on and use services in the cloud in a very big way. So building an app locally is just not possible. We're not writing something that executes on CPU and we can put it on another CPU. We're consuming and using a lot of cloud services. So to expect us to be able to just transplant from our machines into the cloud and expect no issues is probably not an accurate way to think of things, especially now that we no longer have the limitations of not being able to replicate production. And I wanted to share a quick video of a demo of how this can look if you're developing locally. And here you can see I've got my a log file. I'm busy tailing my logs with the serverless framework. And I'm now going to invoke the function in code that you see on the side here with the SLS invoke command. And this is executing Lambda in AWS itself. It's not a local invoke. So now I'm getting the actual results of a Lambda function executed remotely. My logs didn't show anything because I have nothing that returns a log, so I'm just quickly adding a log. And yeah, I've got typos in here because this was written while I was sitting in the dining room, or recorded while I was sitting in the dining room looking after kids. Yeah, forgive me. And now that I've got my console log, I'm going to deploy my changes to my function to AWS. But instead of the regular deploy command that you might be used to, I'm going to use the deploy function command. And this command takes literal seconds to deploy just my code changes to AWS using the SDK, not CloudFormation. And I can cut this or sped this up in any way. My code is now in Lambda within seconds. And I now can invoke it again using my ZSH history. I can invoke my Lambda function in the cloud. And in a few seconds, I'm going to see logs appear for my test as well, so that I can now debug this. And there I've got my console log. And now I can go ahead and make more changes to my code that I need. Let me use my ZSH history to deploy this function again. And in a few seconds, that function is going to be deployed again. There we go. Now I can invoke it again using my history. And this invoke takes a little while because my Wi-Fi in the dining room was not the greatest. But in a few seconds, that invocation completes. And I'll now get some logs as well. And that's pretty much the loop that I use on a daily basis, and we do internally at Serverless as well, where you can develop directly in the cloud and make things relatively quick and simple. And yeah, we've come to the end here, and I need to, there we go. Thanks so much for letting me talk. I hope the information that I presented was clear to everybody. But if you have any questions, now's the time. Please feel free to drop them in. And feel free to get in touch with me afterwards as well if you have questions that weren't answered today.
So thank you very much, Gareth, for this great introduction. And I've seen I've seen a question, but it has been withdrawn. So I'd like to invite all of you to ask your questions in case you had some. And sorry again for the little interruption we had, but on the other hand, it's good to fix things as soon as they're broken, and it seems that we all managed all together to fix the thing. Thank you very much, Gareth. So you were talking about using all the tools and environments, etc., in the cloud to develop. I'd like to just ask maybe a naive question if also, let's say, the team, if the team is purely in the cloud, meaning just remotely connected to each other, to which degree does this have an impact on especially cloud native development or, let's say, serverless development?
Well, the interesting thing is, traditionally, with teams sitting locally to each other in the same office, having local development environments often becomes easier to manage because everyone's together. You know, the new guy joins the team, you sit next to each other, you install things on their computer and get it up and running. So that makes life a bit easier. But with companies and teams moving more into the cloud and building things in the cloud, a lot of companies are going serverless and don't really realize it as well. They're just consuming these cloud services and moving more towards a serverless application without knowing it. Mm-hmm. And being remote means that having these techniques to help you develop in the cloud directly, like AWS organizations per developer, means that you don't have teams trampling on each other. So if I deploy something that I want to test and somebody else deploys something they want to test, we're not negatively interacting against each other and overwriting each other and so on. But we can still integrate later into a shared environment that you find. And these practices were set up before the pandemic, before we all started going remote, before remote was a really big thing. So it's nice to see this continuation where tools we were using to begin with are kind of finding their use in the remote culture too.
Cool. So it's a good reason to move to sunny places as you did. Okay, so as there are no more questions, I'd like to say a big thank you for opening up this conference with this really inspiring talk. I think these are really the fundamentals of serverless development, which everybody should consider. And here comes the questions. Let's go to that. Let me please read it. Do you think that unit tests and mocking are now unnecessary and an anti-pattern in a serverless environment?
So my answer is yes. Mostly because of the experiences I've seen myself and working with other teams in the issues that can come up when you're writing code that you run locally and then you push it into the cloud. And so many times I've seen folks say, I've got this code, I'm running it locally, I've got unit tests that execute them in our CI/CD system or whatever environment. And then I go into AWS, it goes to Lambda, and it's not working like I wanted to. And 9 times out of 10, we find it's because of the differences in how the way the Lambda environment executes code is very different to how your Intel or ARM, whatever CPU you've got does things on your own machine. And there's no way to account for these differences as well. You might decide, okay, I'm going to build something that's going to replicate this and do things exactly like Lambda does, but then AWS goes and changes it out from under you. And you might not see that change. They might not announce that change. They do it often. And if you're not testing in the cloud, you're not going to see that change. And that could eventually affect your ability to go into production. And a lot of teams will say to me, but unit tests and mocking locally and that feedback loop local is so fast, I'm going to lose that. But often what I find is that you get those couple of extra seconds back on that feedback loop, but then you push it into the cloud anyway, and then you spend a day or two fixing errors that you didn't see locally because you weren't testing there in the first place in Lambda itself. So all the time that you may have saved gets lost because you've now got other issues you need to solve instead. Yeah.
Cool. Thank you so much. And thanks also for the really interesting question. And having said that, I wish you a great day out there in Portugal. And I wish all of you, of course, a great conference day. We meet around the keynote after lunchtime. And in the meantime, you see plenty of sessions from the API conference and from the serverless architecture conference. And as I said in the beginning, everything is accessible to you. Choose what you like to see. In case you miss something, you can go later on and watch the recorded session. Of course, then you cannot discuss anymore with the speaker. But on the other hand, stuff doesn't get lost. Having said that, I wish you a great day.
Cheers. Thanks so much.